Hello and welcome to the Hubble Cast, the podcast that helps you go beyond Earth. I'm Sama Bukhamseen and I'll be your host for this podcast. For today's episode, I'll be discussing dwarf galaxies. I actually got this topic recommended from a subscriber's comment in a previous video, and I thought it would be a great topic to discuss because it's quite a new topic for me and a topic that I'm not too educated on. So I thought it would be a great idea to challenge myself by choosing it. And I obviously conducted all the research that was required for me to create this episode for you. So, to begin with, we must know that not every galaxy is made the same. Some are many orders of magnitude smaller and fainter than their bigger counterparts, and they have fewer stars in them. However, this does not imply that those little galaxies are any less significant for our understanding of the universe and its evolution. Many people believe that all we need to understand the universe is to understand and study the large and massive galaxies, but really, this couldn't be farther from the truth. We actually also need to understand these little galaxies as they can be crucial to our overall comprehension of the universe. The most prevalent type of galaxy in the universe is actually the dwarf galaxy, but since they are far less bright than the bigger galaxies, they are harder to see, and that's why they usually go unnoticed. The majority of dwarf galaxies, often referred to as satellite galaxies, are found in galaxy clusters and as partners to bigger galaxies. So it's pretty rare to find these dwarf galaxies on their own and standing individually. Rather, they'll be part of a group cluster or a partner to a larger galaxy. Now, as I mentioned, understanding the formation of these dwarf galaxies and their interactions with bigger galaxies, like the Milky Way, could be essential for modeling cosmic history as well as for making future predictions about the structure of the universe. So it really gives you an idea of how important it could be to understand these dwarf galaxies, as we could literally map out the history and we could make predictions for the future of the universe, which is a really incredible thing that we might be able to do. Now, dwarf galaxies are thought to be formed by the gravitational pull of larger galaxies, either during their creation or when two larger galaxies collide, as will happen in billions of years when our galaxy, the Milky Way, and its neighbor, the Andromeda, collide. And essentially, the colliding galaxies are torn apart by these encounters, releasing jets of gas, dust, and even stars, and a significant portion of material continues to be absorbed back into the galaxy formed by the collision, although some of it could become dwarf galaxies that continue to circle this galaxy. So, this is one of the ways that dwarf galaxies are thought to be formed. It's essentially with the collision or the creation of new, larger galaxies. And essentially, the quantity of stars in each of these corresponding groups of stellar objects, gas, dust, and dark matter is what distinguishes dwarf galaxies from ordinary galaxies. So many people question, what makes dwarf galaxies different from ordinary galaxies other than their size? And it's pretty much just comes down to the quantity of stars and stellar objects that really distinguishes the dwarf galaxies from the ordinary galaxies, obviously aside from the size difference. Now, dwarf galaxies can have a few billion stars or many fewer stars than full-sized galaxies like the Milky Way, which have hundreds of billions of stars. And the Segway 2, which is one of the tiniest dwarf galaxies with as few as 1,000 stars, is one of the faintest dwarf galaxies. And it really gives you an idea of the difference between the stars. The Milky Way can have up to hundreds of billions of stars, whereas this Segway 2, the dwarf galaxy, only has around 1,000 stars. So there really is a great difference between them. And Segway 2 is 20 billion times less bright than the Milky Way, yet it is 900 times as bright as the sun. So it definitely is still a very bright object in the universe, but when you compare it to the Milky Way, it really doesn't seem that bright. Now, there are three main types of dwarf galaxies. To begin with, Even though they are smaller, dwarf elliptical galaxies have many characteristics similar to larger elliptical galaxies. These dwarf galaxies lack recent star birth because they have relatively little gas, and gas is basically the building block for star formation. So since they lack this gas, there isn't really new star birth. And stars in dwarf elliptical galaxies have a total mass that ranges from 10 million to a billion times that of the sun. The sizes of these dwarf galaxies range from 3,000 to 30,000 light years. And by contrast, the Milky Way has a diameter of around 106,000 light years. So it really is a drastic difference between these dwarf galaxies and between the Milky Way in terms of their size. Now, astronomers refer to the reduced proportion of heavy elements in the elliptical dwarf galaxies as metallicity. And elliptical dwarf galaxies must be quite old because each new generation of stars contains more metals. And these are essentially elements that are heavier than hydrogen and helium. Now, dwarf spheroidal galaxies are at the very bottom of the brightness spectrum for dwarf elliptical galaxies. Since they're so faint, we have only so far been able to find them in the Milky Way's immediate neighborhood of around 20 galaxies. So these galaxies are much more difficult to spot and find, and they often go unnoticed because they're really faint. And that's why astronomers and astrophysicists have only found these galaxies that are near the neighborhood, near the Milky Way. And these dwarf galaxies are also far smaller than most dwarf elliptical galaxies, while having a more spherical form than the elliptical dwarf galaxies. And the most active and dense dwarf irregular galaxies are referred to as the blue compact dwarfs. And the exceptionally blue color of these galaxies, which have diameters under 10,000 light years, is caused by hot, freshly formed young stars. Now, given that our own galaxy, the Milky Way, has a spiral pattern, spiral galaxies are perhaps the most well-known to humanity. And spiral shapes can also be seen in dwarf galaxies. They contain enough star matter to make around 1 billion suns, which is mind-boggling. Now, smaller than 16,000 light years in diameter, spiral dwarf galaxies have low luminosities, also known as brightness. And compared to dwarf elliptical galaxies and dwarf irregular galaxies, they are likewise rather few. Now, many astronomers believe that spiral dwarf galaxies undergo a transformation into dwarf elliptical galaxies, especially in compact galactic clusters. And because of how faint they are, the majority of dwarf galaxies discovered by astronomers thus far exist in relatively close proximity to the Milky Way. And our galaxy is surrounded by as many as 50 smaller satellite galaxies. So astronomers have kind of focused on these dwarf galaxies and have been able to discover the ones that are in close proximity to our galaxy. And here are some of the most significant. So the largest of these, and arguably the most infamous dwarf galaxy, is the LMC. It is a satellite galaxy of the Milky Way located about 160,000 light years away. The Tarantula Nebula, the brightest stellar nursery next to the Milky Way, is one of the several luminous star-forming areas or nebula in this gas-rich satellite dwarf galaxy that is 1/10 of the size of the Milky Way. And the Milky Way and other galaxies are thought to have pulled on the LMC, giving it an uneven form according to astronomers. Now, the Sagittarius Dwarf Spheroidal Galaxy, also known as the Sagittarius Dwarf Elliptical Galaxy, is one of the Milky Way's nearest dwarf galaxies, located only 50,000 light years from the galaxy's center. Its 10,000 light year diameter loop-shaped dwarf galaxy is located at the Milky Way's poles. The dwarf Sagittarius Spheroidal Galaxy is made up of 4 smaller globular clusters, the brightest of which, M54, was identified prior to the 1994 discovery of the dwarf galaxy. So it's really interesting how they were able to discover the M54 before they were able to discover the initial dwarf galaxy. Now, a remarkable illustration of how dwarf galaxies may affect the bigger galaxies they orbit is the Sagittarius dwarf spheroidal galaxy. Researchers with the GAIA project of the European Space Agency found in 2018 that between 3,900 million years ago, the Sagittarius dwarf spheroidal galaxy passed our galaxy, causing the Milky Way center to ripple. So it's really fascinating to see how such a small galaxy was able to have such a profound impact on the Milky Way. Even the possibility has been raised by scientists that the Milky Way's spiral arms may have formed as a result of two collisions with the Sagittarius galaxy. This dwarf galaxy's present observed form of a flowing long loop might have been caused by the violent encounter that created it. And unsurprisingly, the first dwarf galaxy found by scientists was a companion of the Milky Way, and Harlow Shapley made the first observation of the Sculptor dwarf galaxy, which is 3,000 light-year distance in 1937. Now, overall, in the past decades, our understanding of these tiny star clusters has expanded, and as a result, so have our understanding of galaxies, the universe, and the Milky Way's position within it. That is it for today's episode. I hope you guys enjoyed getting an insight into something so close to our home, the Milky Way, while still being its own unique celestial object. Make sure to stay tuned for future episodes, and goodbye.